Good morning. Today we'll discuss about voltage division rule and current division rule. In the last lecture, we have seen about resistors in series and also resistors in parallel. We have seen that when the resistors carry the same amount of current, then they are considered to be in series. So these resistors are carrying the same amount of current. So these are considered to be in series. So and their equivalent resistance is given by summation of the resistances. Like if let us suppose these are R1 and R2, then their equivalent resistance is R1 plus R2. Whereas when the resistors do have a common potential across them, see the potential drop across this element is equal to the potential drop across this element. The currents are not same, but the potential drops are same. So in that case, these resistors are considered, they are said to be in parallel. And for determining the equivalent resistance of parallel connected resistors, we have determined this particular formula. Right, and we have solved numerical problems on this. So this is a quick recap question of what we have gone through in our last lecture. See, we need to determine the equivalent resistance between the terminals A and B. You can easily see that this resistance, both are across the same terminals, right? Which means that they have the same voltage drop across them. So these two are considered to be in parallel, right? And next, for the equivalent one, this one will be in series, and for again that one, this will be in parallel. So like this, see, I will try to see. First of all, these two. So these two are in parallel. So the equivalent value is 1 by 6 plus 1 by 3, isn't it? So what is its value? LCM is 6. 1 plus 2, it is 3 by 6, it is 1 by 2. So 1 by R equivalent is 1 by 2. So the R equivalent value is, it is 2 ohms, isn't it? Now these two, they are carrying the same current, isn't it? So which means that they are in series. So what is the summation of these two then? R1 plus R2, it is 5.8, right? So if I redraw the circuit now, this is 12. In the middle one, I do have already 4, and again I do have 2 ohms, and again I do have 5.5, and here I do have a 5.8 ohms resistor. Right, this is 4, this is 2, this is 6, 12, this is 5.5, and this is 5.8, isn't it? So now if you carefully see, these two are in series, right? So if I remove these two and if I join them into a single resistance, see these are in series, right, carrying same current. So its value is 4 plus 2 is 6. So I can write it as single resistor, 6 ohms. Now if you see, these two are not in series, they are not carrying the same current. There is some extra node here present. But whereas these two, they are in parallel, isn't it? So what is the equivalent resistance? It is 1 by 12 plus 1 by 6. LCM is 12. So 1 plus 2, it is 3 by 12, it is 4, right? So I can replace these two resistors with 4 ohms. So I'll get 4 ohms here. This is 5.5 for me. And here I am getting a 5.8 here. Now these two are in again series, right? So it is 4 plus 5.5, it is 9.5. And again in parallel I do have 5.8. This is B, this is A. So the final value will be, what is the final value for me now? It will be 1 by 5.8 plus 1 by 9.5 is equal to 1 by R equivalent. So if I can determine the value of R equivalent in this case. So this is how we will be simplifying the networks when the resistors are connected in series and parallel. Right, this is what we have seen in the last class. Now, in today's class, we will see how to identify or how to determine the voltage drops and currents in branches when the resistors are connected in series and also parallel. And for that, there is a rule which is followed in electrical engineering, a simple rule, which we call it as voltage division rule and current division rule. And we will see where these rules are applicable and how we can employ them for determining the voltage drops and currents. So I hope that by the end of this lecture, you will be able to determine the branch currents and voltages using voltage division rule and current division rule. It is current division rule. Okay. Now, so I will start with the basic introduction, why these rules are employed, and next we will move on to voltage division rule and current division rule, and followed by some numerical problems on this one. So, first of all, coming to the introduction, these voltage division rule and current division rule, these are common fundamental principles in electrical engineering. These are employed for determining or analyzing. They are used for determining the circuit response in simple circuits and analyzing them. And particularly in case of power electronics, communication side, digital circuits, these will help us in determining the responses in elements very quickly. And first one is current division rule. It works on the resistors which are connected in parallel. So we have seen the current division rule here. See, we have seen that if there is a parallel circuit, right? If there is a parallel circuit, then the current automatically what happens? It gets divided. Am I clear? Right? So the current gets divided in this format, right? So any parallel circuit basically acts as a current divider. So the current gets divided in all of its branches. Now this is a figure. See, I is the current which is flowing into these two resistors R1 and R2, and see, let the current be I1 and I2. Now our target is in what ratio it is being divided. Right. See, if you carefully see, these resistors are connected in parallel, isn't it? Which means that they do have a same voltage drop. I'll take it as V. Isn't it? So what is by Ohm's law? You know by Ohm's law. What is Ohm's law? Ohm's law states that, see, this is my R1. This is the current which is flowing. And the voltage drop across them is V. Same V across these two because they are in parallel, right? So I can write for this one, I'll write it as by Ohm's law. V is equal to I into R1. By Ohm's law says that voltage is proportional to current. V is equal to I into R, right? And for this part, I can write it as V is equal to, sorry, this is V is equal to I1 R1. This is V is equal to I2 R2. And the voltage drops both are same. So if I rewrite them, what is I1 now? It is V by R1 and it is I2 is V by R2. Right. And what is the total current now? You know that I is equal to I1 plus I2, right? I is equal to I1 plus I2. And you know the I1 value, V by R1. I2 value is V by R2. If I substitute them, see, V into, if I take it as common, 1 by R1 plus R2. I'll write it here. For your sake, V by R1 plus V by R2. If I take V as common, it is 1 by R1 plus 1 by R2. If I take LCM, I'll get R1 R2 as LCM, R1 plus R2. So this is current in terms of resistances. So if I take V is equal to, this is the equation. Now if I substitute this one here, what is I1 now? You say this is 1 by R1 into I into R1 R2 by R1 plus R2. So if I strike it out, see, this is the expression. This is I1. So I1 current is nothing but it is proportional to R, opposition path resistance, not its own resistance. Similarly, I'll get I2 is equal to I into R1 by R1 plus R2. Okay, see, this is what we have obtained. So from this, what we can observe that currents in parallel branches they will be inversely proportional to the ratio of their branch resistances. That is what your Ohm's law says. V is equal to IR, right? So if V is held constant, then I is equal to V by R, right? So if V is held constant, I is proportional to 1 by R. If there are n number of parts, let us suppose there are n number of parts, I1, I2 and I3. The ratio is equal to 1 by R1 is to 1 by R2 is to 1 by R3. This is the current division rule. Right. The currents in parallel branches will be inversely proportional to the branch resistances, which means that the ratio of currents in the parallel branches is equal to the ratio of inverse value of the resistances. Understood? So, I hope that now you have understood what I am trying to say. Right. So, which means that, let us suppose if I do have a current here, 1 ampere of current is flowing. If there is 10 ohms here, if there is 20 ohms here, how much current will be flowing here? Normally, if it is also 10 ohms, then I can say that 0.5 amperes current will be flowing. But now here I am taking it as 20 ohms, right? So in that case, the current, let us suppose this is I1, this is I2. I1 is to I2 is equal to, you are supposed to take 1 by 10 is to 1 by 20. Understood? So 1 by 10 is to 1 by 20 means it is 0.1 is to 0.05. Right. This is the ratio. So if I simplify it, what I will be getting? I will be getting it as 2 is to 1. This is the value of I1 is to I2. So which means that out of total of 1 ampere of current, 2 parts will be flowing into this one and 1 part will be flowing into this one. Am I clear? So this is current division rule. Whereas voltage division rule, it states that, see, current division rule is applicable only to parallel circuits. Voltage division rule is applicable to series circuits. So this is a series circuit. Now you can see that there are two resistors which are connected in series, right? So this is a voltage division circuit. So same current is flowing in this one. Your V1 is equal to I into R1. Your V2 is equal to I into R2. And your total V is equal to V1 plus V2. So if I take I common, it is R1 plus R2. Isn't it? So, see, V is equal to I into R1 plus R2. So what is I value? V by R1 plus R2. Now if I substitute this one here, see what I will be getting. V1 is equal to R1 into V by R1 plus R2. V2 is equal to R2 into V1 by V1 R1 plus R2. See, it is proportional to the same value, whereas in the same case of currents it was inversely proportional. Right. So it can be said that the voltages, see, again I can simply apply Ohm's law. V is equal to I into R. In series circuits, I is constant. So V is proportional to R. So if there are n number of series connected resistors, this is the ratio which is applicable. The ratio of voltage drops in series branches will be equal to the ratio of the branch resistances. This is the mathematical expression. If this is 4 ohms, this is 6 ohms, and this is 10-25 volts applicable. So in what ratio the voltage will be divided? Very simple, I can say. V1 is to V2 is equal to 4 is to 6. Then what is V1? V1 means 4 by 4 plus 6 into 25, isn't it? Then what is V2? 6 by 4 plus 6 into 25. I think you know how to do this type of ratio problems, right? So I am directly taking these equations. So this is the concept of voltage division rule and current division rule. Both are applicable for, current division rule is applicable for parallel circuits, whereas voltage division rule is applicable for series circuits. And in the next